Hi students, welcome to the third quarter. This is our lesson from Monday 125-21. We're going to walk this through, so stick with me. Again, the idea is for you to do the Desmos at the same time and to pause it when you reach a certain place. All right? So we're starting out with this do first, and the idea behind this do first is talking about an ordered pair on a line. So if we look at this line, we're saying, what is a possible ordered pair that could go on here? So what a line is it's a collection of all these possible points. So pick a line, see if you do it. So here's just a few of the points I selected that have nice, really pretty numbers. So if you look here, these are all lattice points because they are on the graph. Remember, our graph goes like this. All the x-axis coordinates are here, starts at 0 and goes positive 1, 2, 3, 4, 5, 6, 7. This way it's negative, right? To the left is -1, -2, -3, -4, -5, -6, -7. All right. And then our y coordinates start here at 0 and it goes up. And our y coordinates are positive, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then when it goes down, they're negative. -1, -2, -3, -4. All right. Now, these points that I put on here, these ones I'm highlighting right now, are all lattice points because they have nice whole number x and y values. All right. But there's an infinite number of points on this line. Let's name a couple of them and see how you did. So let's start with this point right here. To find that point, I start 0, 0. I said, oh, the x value is always first. It's -2 and then up to 5. So this point would be -2, 5. All right. This point right here, notice I'm at over to -1 and then up to 7. So that'd be -1, 7. And again, the x value is always first, the y value second, just like the alphabet. This point right here is 0, 9. This point right here is 1, 11. All possible values. If you did one of these, you could have had -3, 3 right here. This point right here is over -4, then 1. So hopefully you're getting the hang of it. These two have both negative x's and y's over to -5, -1. And this one's -6, -3. And so you need to be able to do this, locate points on a line and on a graph. If not, make sure you check in with your teacher. We'll walk through it. We'll give you practice about how to graph those points and to find them. Now, just a little insight. All these things that come between those are also points. They just would have decimals, decimal point values. So like if I wanted to do this one right here, it would be -3.52, -3.5, 2. So there's really so many more that I can't even talk about them all, but you need to be able to do this skill. Same thing right here. You really need to be able to, on the second slide, be able to pick points that make this true. So when we say type an ordered pair that is the solution to this equation, what we're saying is, what's an x, y value that we can plug into this equation to make it true? So think about it. If I put some number here, what has to go here to make it true, or vice versa? So I'm going to just put 10 right here. If I put a 10 in for x, what's 10 plus 2? Well, 10 plus 2 is 12. So this 12 could be for y, and the 10 could be for x. So that point 10, 12 could work in this equation. In fact, you can try just about anything in there. And so if I erase this and this, choose a number. I'm going to guess what you're thinking. Let's say you chose 0. Well, if I plug a 0 in there, I get a 2 here. So the point could be 0, 2. All right? What else could I put in there? Well, the answer is anything. I could put 3.1. 3.1 plus 2 is 5.1. So I could say 3.1, 5.1. All right, so hopefully you're seeing you are choosing an ordered pair that works in this equation and that numbers are endless, right? We could put 1,000 in here. What's 1,000 plus 2? 1,002. So our ordered pair would be 1,000, 1,002. All right. Now when you think about that, go ahead and when you plug those numbers in, put one of those numbers in and use a smaller one. So I'm going to say 2. 2 plus 2 is 4. So that is a point that could work. Oop, I need a comma. So if I put 2, 4 in there, I have some other numbers. And look, it shows up right there on my graph. All right, so think about that. All of those points match the graph, y equals x plus 2, and they show up as points here. All right? So we're really going to talk about two topics today. The first topic, we're calling topic 3, is what is a solution? So when we're looking at a line or a set of lines, what is a solution for that system of equations or that singular equation? So this first slide 18, if we say, what does it mean for a point to be a solution on a linear equation? Well, it means that it works for that equation. So if I said 2, 5 is a solution to the equation y equals 2x plus 3, how could you check that claim? How could you say, I agree or I disagree? Take a moment, pause, and think about it. So you can do it by plugging it in, right? We have this point 2, 5. This is an x value, this is a y value. So if y equals 2x plus 3, we're going to take the 5, insert it for y, and the 2, and insert it for x. So let's see if that works. If this is 5 equals 2 times my x value, which we said was 2, is this true? Try it out. Well, we just multiply 2 times 2 is 4. 4 plus 3 is 7. Does 5 equal 7? No. So this is not a solution, but that's how we test it. Maybe you could come up with a solution, and you could do that by just plugging in a number for x and getting a y value. So if I plugged in 1 right here, I will get 2 times 1 plus 3 is 5. So 5, 1 is a solution for this. All right, so now we're looking at slide 19. The question is there an ordered pair that is a solution to the linear equations describing both of these lines? So again, we're trying to figure out what does it mean to be a solution? And so if there's two equations, what is the solution? So think about it, pause, and try it out. Well, is there an ordered pair? The answer is yes. Okay, explain your thinking. Okay, the thinking is the solution is where the two lines intersect. And so you can see this point, -4, 1. The solution to this pair of equations, we also call them a system of linear equations, is the point where they intersect. That point is -4, 1. All right, so think about that. Two lines on the same graph, their solution is where they intersect, okay? So, look at these two equations. Is there an ordered pair that is the solution to these two? You can't see them on the graph, right? We have two, so how would you find out if there is an ordered pair? Well, we'd use something called substitution. And here we call it equal value substitution. So I want you to pause this and I want you to try to remember how to do that equal value substitution and then come back. So go ahead and go to the next slide on slide 21 to see how this is worked out, or pause and try it out yourself. But what you see here is we have y equals -x plus 5 and y equals x plus 1. Since we know that y equals y, okay, anything equals itself, right? We can say that this side, -x plus 5, is equal to this side, x plus 1, and then we're just going to do our steps. We're going to add x to both sides. We'll get 5 equals 2x plus 1. Then we want to get the numbers to the same side, so we subtract 1 to both sides, and we get 4 equals 2x. 2x divided by 2 is x. 4 divided by 2 is 2. All right, so we know x is 2. In order to find y, we just plug back into the equation. Y equals x plus 1, we plug 2 in for x, and we get y equals 3. And the solution is the point 2, 3. If you look at this graph here, then you can see this is the graph of y equals x plus 1, and the blue line is y equals negative x plus 5. So if you graph them, you could also see that that point right there, 2, 3, is the solution. Again, the solution is where the lines intersect. And so if you move a couple of these forward, you can see here's another solution. Okay, it's where they intersect at negative 1, negative 1. Right. Will these ever have a solution? What do you think? Well, the answer is yes, because they will eventually intersect, right? And so even if you can't see the intersection, if you know they will intersect, you know you have a solution. This is a set of parallel lines. So what do you think? Does it have a solution? Yes or no? The answer is no. All right, and on slide 25, it gives you your three options. Either they intersect with one solution, they never intersect, there's no solutions, or they're on top of each other. They coincide. There's an infinite number of solutions. All right, so here on to topic 8. We are going to review how can I solve a system of equations using substitution. Slide 27 and 28 is a fun activity. You're going to try to do an equal value substitution, and when you get that point, plug it in right here and see if you can zap where it hits on this line. Okay, try it a couple of times, and when you're done, go ahead and try slide 28. It walks through the problem for you. If you're still stuck, right, this is how you work out the first part to get x equals 10. And then remember, how do you find what y is? You back substitute in, and you place that 10 in for 2, and you could get 20 plus 7, which is 27. All right, here we are on line capture number 2. Again, this is another fun one where there's 4 lines hidden here. Y equals negative 2x plus 45. And what you're going to try to do is capture all the lines by entering ordered pairs for points on the line. Again, you're just going to plug those points in here. All right, so I'll let you do that one on your own. I want to work on this type of substitution right here today. This one says y equals 3x plus or minus 1, and the second equation 2x plus 4y equals 24. We're going to substitute in for our second equation using this 3x minus 1. So go ahead and pause, try that out for a little bit, and then come back here when you're ready. If you think you got the right ordered pair, go to the next screen, plug those in right here. You can plug those in right here for your x coordinate and your y coordinate, and it'll show you if you did it correctly. All right, if you didn't do it correctly and you want to walk through this, let's take a look here. So y is equal to 3x minus 1. We're going to take this and we're going to plug it in for y. And so what we end up having, let me get another color here, is the 2x plus 4, but instead of y, we're going to put this 3x minus 1. Everything else is the same. Instead of this y, we have 3x minus 1. Thus, the substitution. Multiply the 4 to 3x and the negative 1 by distributing. So 2x plus 4 times 3x is 12x. 4 times negative 1, negative 4. Equals 24. 2x and 12x combine to give you 14x. Minus 4 equals 24. Add that 4 to both sides, and you get 14x equals 28. Now, do you know what times 14 is 28? If not, you just need to divide both sides by 14. I'm running out of space here. 28 divided by 14 is 2. All right, so once you find what x is, remember, plug it back in. So I know x is 2, plug it into 3x minus 1. I'm going to clear this. So I have y equals 3x minus 1. I already know x equals 2, so I'm going to substitute that back in. I get 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 is 5. So I get the ordered pair 2, 5. All right, and so you can go ahead and plug that into this next slide. You get 2, 5. All right, now that's all of our time for today. Go ahead and get to this Delta Math assignment on the last slide. When you click on that, there's more practice for you to have. Join your teachers in office hours. All right, see ya.